Hello, Year 11s again. I'm now going to try to answer questions 6 to 9 in this video. Let's see if I can do it quickly. Hopefully you had a chance to watch video for number 5, question 5, and then video for question 12. It should tie in, hopefully, what you need to do. Obviously, in order to do all of them, you need your exercises 3A to 3F. You have to be able to do them all, including 3G, sorry, 3A to 3G. Without any of that, you can't you can't do these questions properly. Yeah. So here we go. Let's do question 6. And it says for m and n rational numbers. Rational just means a number that can be expressed as a fraction. So for example, 3 is a rational number because you can write it as 3 out of 1. 1.5 is a rational number because you can write it as 3 over 2. Whoops, what happened there? I think I was writing too close to the top. Let me just fix that. 1.5 can be written as 3 out of 2. So again, that's a fraction and it's a whole number on both top and bottom. So those are called rational numbers. Now it says for m and n that are rational numbers, show that mx squared plus, so I'm going to write it here, mx squared plus 2m plus n times x plus 2n. Okay, I'm just going to write y instead of 0 equals to 0. But this is your equation. Has rational solutions. So your answer should not have a surd. Irrational numbers are the ones with surds and whatnot. Okay? So, here we go. If we know that it's going to be rational, we just got to prove it. Now, it has rational solutions means that you can find x-intercepts. Now, if you can find x-intercepts, the only way to find x-intercepts is you have the discriminant is either equal to 0, which means you have one x-intercept, or discriminant is greater than 0, and that tells you have 2 x-intercepts, right? So essentially what you want is you're going to have discriminant greater than or equal to 0. That's the only way you're going to have solutions. And apparently when you do, they're going to be rational solutions. So let's have a look. The first thing you need is to find out the discriminant, which is b squared minus 4ac. In our case, again, remember a is the coefficient of x squared, which means the number that's multiplied to x squared, which is m. You have also the value that's multiplied to b, or b multiplied to x, so this is bx there, and so that means this is your b equals to 2m plus n. And finally you got c is 2n, the one without any x values at all. Okay, so if I put it all together, I'm going to answer the question. I'll say, all right, well, b squared 2m plus n all squared minus 4 times a, which is m, times c, which is 2n, right? So I'm just following on with a b squared minus 4ac, yeah? My discriminant, I work this out, I expand it, that gives me what, 4m squared, then double 2m times n, so that makes it plus 4mn, and then square the last term, so plus n squared, minus, and you times this together, 4 times m times 2n, so that's 8mn. Okay, and this tells me the discriminant, and I'm simplifying it, 4m squared. 4mn minus 8mn gives you negative 4mn plus n squared. Okay, so this is my equation, and this is my discriminant. Now what I want to find is when it's equal to or greater than or equal to 0. So as I say that in order to answer this question, you always have to sketch the graph, okay? Now this is tricky because you have m and n in both the cases there. Now all you have to really show is you gotta show, if this is a perfect square, you're always gonna have rational solutions, okay? So here we go. If I were to try to factorize this a bit further, I'll take out 4, and I get m squared minus mn plus n squared on 4. True? And what I can see is, if I factorize this even further, you can see that this will give me now m minus, okay, think about it, I got to double something to get negative mn, and I square something to get this value here. So you can see that if I had half of n, square of this will give me n squared on 4, right? And how do I explain this? So when I look at this, I know it's a perfect square because I know half of this b term, see half of this, half of negative 1 on n. Okay, another way to think about it is I can write it like this. I can write it like negative nm. And I can tell that half this b term, okay, half of that will give me negative 1 on n. But then if I square that, okay, if I square that, sorry, not negative 1 on n, what am I doing? Half of that is negative half of n. And if I square that, I will get n squared over a quarter. True? Because the square of 1 is 1, square of n becomes n squared, square of the 2 gets you 4, yeah? And that conveniently is the same thing as this term. If I took if I try to expand this equation here, if I expand that, that becomes m squared. M times negative half n is negative half mn, but remember you're doubling this as well, and that conveniently cancels out, becomes negative mn, which is that. And then if you square the last term, you get n squared plus 4. So I know this is a perfect square. See, I know this is a nice perfect square as it is. So if I just take this away and I'll just do it again, this really just means this is a perfect square, and I know it's m minus half of n squared. If you don't like that sort of notation, then I can write it as n over 2, if you like that way. Okay, but remember you have the 4 at the front, this is still the 4 there, so really you got 4 times m minus n on 2 all squared. This is your discriminant. Okay, now why is this always going to give you a rational solution? Well, you think about it, if you're going to get to sketch this graph, if you're going to sketch it by discriminant by m, right, what you can see is, reading from exercise 3D, you can read this. This is positive graph, positive 4. It's narrow. So it's positive and it's narrow. This is m minus n on 2. So if you let it equal to 0, it tells you that you're moving to the right by n on 2. So right by n on 2. So n over 2. Okay, and it doesn't go up or down. It's a smiley face. So if I just do that, what you can see is this graph for all m values, you're always going to get discriminant greater than or equal to 0. Okay, so discriminant is always greater than or equal to 0. It doesn't matter what m you choose. You can choose any values for m. Okay, but just because you have all of it, just because you have solutions or x-intercepts, it doesn't mean that they are rational. So how do you know that it's always going to be rational? Well, remember, if this is the discriminant, okay, this is the discriminant, I'm going to do this. If this is the discriminant, how do you know you're going to have a rational answer? Well, think about it this way. So remember, at the end of the day, you're trying to find the x-intercepts, right? And the x-intercept formula, which is negative b plus minus square root of b squared minus 4ac all over 2a. True? And we already just figured out that b squared minus 4ac, which is the discriminant, you got your answer here. This is your discriminant. True? So what if I replaced it in here? And what you see is if I replace that, if I took, instead of b squared minus 4ac, I will now have square root of 4 bracket m minus n on 2 squared. This is a plus minus over 2a, and this is negative b, right? What I want you to see is, before you even try to simplify all this, what you already can see is this is going to end up being negative b plus minus, now the root of 4, which is 2, and the square root of the squared cancels out. These two cancel out, and the square root of 4 is 2. So you end up with n minus n on 2. See, there's no surds. So if it has no surds, it will always be a positive value. or positive or negative value, but it's always going to be a rational number because you don't have any surds. See, root of 3 is irrational. Root of 5 is irrational, but you're never going to have that because it doesn't matter what m values you choose or n values you choose, you're going to square root it and it's going to cancel out the surd. It's going to cancel out this square root symbol. That's what I'm trying to say. Because you've got the square, and square root of 4 is always going to be 2. So it doesn't matter what m and n is, you're always going to get a nice rational number because there is no decimal or irrational number basically. Okay, and so that's why it's hard to explain when you're doing your answers here. But that's the reason why. So as you're showing it, you can see if it's a perfect square. Anytime you do the discriminant, if the discriminant is a perfect square, you're always going to have a rational solution. Because if the discriminant is a perfect square, like I just showed you, so I'm just going to reiterate the same idea. I'm just saying negative b plus minus square root. Now normally it's the discriminant over 2a, true? If the discriminant is a perfect square, you will always have perfect square. You will always end up with negative b plus minus, and the square root and the perfect square will cancel out. That's why. So you end up with negative b plus minus and whatever the bracket is over 2a. That's why. So that will never have a square root. If it never has a square root, it's never going to be irrational. It's going to be rational for every solution you always have. So the aim is, will it have a perfect square? That's what question 6 is about. Okay. All right, let's do question 7. Hopefully it's not something that convoluted. Question 5 is always the best to sort of understand it. Question 8 should be good too. Let's have a look at question 7. It has no real solution. So this one should be a bit easier to understand. So let's look at question 7. P times x squared plus 2 bracket p plus 2 multiplied to x plus p plus 7. Okay, remember this is your quadratic equation. And you want to make sure that you have no real solution, meaning no x-intercepts. The only way to know that you're not going to have any x-intercepts, remember, is when the discriminant is less than 0. Because if the discriminant is negative, you can't find the x-intercepts. Remember, the x-intercept formula is negative b plus minus square root of b squared minus 4ac, which is your discriminant. True? If this is a negative number, that's a problem because you can't square root a negative number, so you end up not having any x-intercepts at all. Okay, so that's the goal. We basically want this. This is what we want. So again, same thing. We need discriminant, which is b squared minus 4 times a times c. B, which is 2. Actually, I'll highlight it again. I'll do it here. This is my a. A is the thing that times to x squared. B, which is 2 times p plus 2, and then finally c. C is p plus 7. Okay, so if I put it all together, b squared, which is 2 times p plus 2 all squared, minus 4 times a, which is p, times c, which is p plus 7. Okay, I know they look complicated, but it isn't. Okay, it's just negative 4p. If you expand it, it's negative 4p squared, and negative 4p, that's minus 28p. Okay, and over here, you're really expanding the 2, which is 4, and you got p plus 2 squared. So if you expand this even further, this becomes 4 times p squared plus 4p plus 4, minus 4p squared minus 28p. Expand it further again, 4p squared plus 16p plus 16 minus 4p squared minus 28p. Okay, so 4p squared minus 4p squared cancels out. I'm just double checking if I've done everything correct. It looks good so far. 16p minus 28p will give you negative, what's 8 plus 4, negative 12p, and that's plus 16. Okay, this is my discriminant. Now, remember, for everything that you get, every time you work out the discriminant, you got to sketch it. If you sketch it, you'll see what it looks like. Now, hopefully, at this point, this is a m. I mean, not m anymore, it's p. So you want to sketch the p-axis by the discriminant, and that's your discriminant there. This is a linear equation. You can see it's negative 12, which is your gradient, times p plus 16. I know it looks a bit different, but really it's the same thing as saying y equals mx plus c. Yeah, this is like your y equals, that's your m, that's your x, that's your plus c. Yeah, it's your straight line equation. You know it's got a negative gradient, y-intercept at 16, so at 16. And if you worked out for the x-intercept, you can see that x-intercept is when you have negative 12p plus 16, and you work it out, negative 16 over negative 12p, and p will be 16 on 12, which is 4 on 3. Okay, so that just means that 4 and 3, let's say it was here, 4 and 3, I've got a straight line negative gradient. There we go, I sketched my graph. Okay, what I'm more interested in is, remember what was the question? You want to have no real solutions, right? Meaning you want the discriminant to be negative. Now looking on the discriminant axes, see this is your discriminant axis, all the way here. The only time it's going to be negative is around in here, in that region. So where on the graph will you have something corresponding to a negative discriminant? Clearly, anywhere down here, yeah? See all of that down there, all of those points here. I'm going to just do the points again. So have a look at question 5, the video for question 5. I'm doing the same thing. All these coordinates here, all the values, if you choose P, anything in this direction, P in this direction, will always give you a negative discriminant. See, that corresponds to a negative discriminant. So we know as long as you choose P to be bigger than 4 on 3, you will always get, because 4 and 3 is right here, that's the spot where 4 and 3 is. If you chose anything bigger, you'll get a discriminant that's negative. Okay? And if you get a discriminant that's negative, that means that you'll have no x-intercepts. This is when discriminant is negative. True? And we can see that if P was bigger than 4 on 3, right there, if I chose any P values in this direction, which means P is greater than 4 and 3, then you'll have a negative discriminant. So answering the question for question 7, find the values of P. Well, P just needs to be bigger than 4 and 3. Okay. All right, hopefully that kind of makes a bit more sense. That's very similar to question 5. The only difference is you got more letters and numbers. That's it. But same technique. You find the discriminant, sketch the graph, and analyze it using exercise 3G. Yeah? I'll do question 8 as well. I'm just going to move this over here so that's a bit easier. Let's move this a bit further down. Okay, so I'm going to move it here. Let's do question 8. Same thing. This one, on the other hand, now has one solution. Okay, so again, question 8, I've got y is equal to, actually it is 1 minus 2p all times x squared plus 8 times p x minus 2, or brackets here, plus 8p. Okay. Again, these are you have to determine your a's and b's and c's. This is my a value. A equals to 1 minus 2p. B, which is 8p. This is your b term. And c is equal to negative 2 minus 8p. Okay. Now, answering the question, you want to have one solution, meaning one x-intercept. The only way you're going to have one x-intercept is if the discriminant equals to 0. So again, you need b squared minus 4ac. You need this to equal to 0. So here we go. B squared, which is 8p all squared, minus 4 times a, which is 1 minus 2p, times c, which is negative 2 minus 8p. Okay. Now we can simplify this further. That's what becomes 64p squared. Take out the negatives, so the two negatives make a positive, so it's plus 4 times 1 minus 2p, but since I took out the negatives from this bracket, it now becomes 2 plus 8p, okay? Which is really just, I'm just using this up here, 2 negatives make a positive. I'll just highlight what I meant by 2 negatives make a positive. See, if you take out the negatives here, the negatives will come outside the bracket, and these 2 negatives here will cancel out to be positive. That's how I got the plus, okay? And then I'll expand it from here again, same thing. This is now 64p squared. This becomes plus 4 minus 8p multiplied to 2 plus 8p, which again now becomes 64p squared plus, and let's expand this. So 4 times 2 is 8. 4 times 8p is plus 32p. Minus 8 times 2 is minus 16p, and that's minus 64p squared. Okay, convenient 64p squared cancels out with 64p squared there, and I get 32p minus 16p, which works out to be 16p, and I got a plus 8 here. Okay, and now I'm really trying to solve for p for when the discriminant is 0, and see, this is all representing the discriminant, so I can just solve for p now, minus 8 on both sides, and therefore p needs to be negative 8 on 16, which means p is negative half. So that means when p equals to negative half, I will have one solution. Now normally what I would say is I'd encourage you to draw it at this step. I'd say draw this graph, right? So what you would normally meant to do is you say this is your discriminant axis, this is your p axis, and you're trying to sketch this graph. Now we can already see it has a y-intercept at 8. It's a straight line equation, yeah? And 16 is your gradient, it's positive, so it's a positive gradient, and you can see it will look like that. And the x-intercept there, or p-intercept, is negative half. So we can see at this point, right at that point right there, when p is negative half, the discriminant is 0. That's what it means. That's the coordinates, because the y-axis represents the discriminant. So that's when you have one solution. If you want to have two solutions, you just got to pick. So this is a side note. If you want to have discriminant greater than 0, clearly it's this region. This is when the graph is above the x-axis, and that's when the discriminant axis is greater than 0. So if you chose p bigger than negative half, okay, which means this direction, any of these direction values, then you will have two solutions, meaning two x-intercepts. If it was another question, if they said no solutions mean discriminant has to be negative, so less than 0, then you can see that you have to choose p less than negative half, because that's the only time, which I'll color here, that's the only time that the graph will have a negative discriminant. Yeah? Because we can see it corresponds, all these coordinates down here all correspond to a negative discriminant. So how do you get those values? You have to choose x values, or p values, less than negative half. Yeah? So that's why if I chose less than negative half, you have no solutions. But that wasn't the question. The question was asking to have one solution. To have only one solution, it clearly is right when the discriminant equals 0, which we solved over here. Okay? So that's answering question 8. All right, let's do question 9 now. So same thing again, same drill. They're all the same drills, by the way. So 9a, find the values of p for which this equation has one solution. See, the one solutions are always the easiest ones because you just want the discriminant to equal to 0. I always encourage you guys to sketch the graph, yeah? I'm going to do b because it says two solutions there, so let's do b instead. b is 2x squared minus 4x plus 3. This is my equation. Equals to p, sorry, equals to p. Whoops. Okay, so if I rearrange it, I get 2x squared minus 4x plus 3 minus p equals 0, yeah? Now, I want to know what values of p such that I will have two solutions all the time. Now, obviously this is a equals 2, b is negative 4, and c is 3 minus p, right? So in order to have two solutions, I need the discriminant to be positive, which means greater than 0. So discriminant, which equals b squared minus 4 times a times c, b squared, which is negative 4 squared, minus 4 times a, which is 2, times c, which is 3 minus p. Simplify this, this gives you 16 minus 8 times 3 minus p. And this gives me discriminant is equal to 16 minus 24 plus 8p. And 16 minus 24 is negative 8. So that's 8p minus 8. This is my discriminant, and remember, as I say, once you get your discriminant equation, before answering any question, sketch it. Okay, so I'm now trying to sketch the discriminant by p-axis, and I'm going to sketch this graph. Now, conveniently, again, this is a linear equation, where you can see that's the gradient, that's m, this is your x, and that's your c. So y-intercept is negative 8. So that's negative 8, 0, negative 8. So when p is 0, discriminant is negative 8, okay? And it's a positive gradient, and if I were to work out for the x-intercept, I can let y equal to 0, you got 8p minus 8, so 8 equals 8p, and therefore p equals 1. So that means, there we go, positive gradient in the straight line, and there we go, this is at 1. So the question is asking, when will I have 2 solutions? You can see on the graph 2 solutions when discriminant is greater than 0. This is your discriminant axis. This is the only time on the graph that it is in the positive region. See, this is when discriminant is positive. So how do you get those? Clearly, if you chose any values for x greater than 1, see in this direction here, you can see that any value you choose for x, if it's 2, 3, there's a coordinate on the graph that corresponds to a positive discriminant. Okay, so the answer for 9b was clearly when p is bigger than 1. Okay, it doesn't matter which value. If p is bigger than 1, you'll ensure that you have a discriminant greater than 0. That's when you know discriminant is greater than 0. So therefore, 2 x-intercepts or 2 solutions. All right. Hopefully that makes a bit more sense. In fact, I think question 9 was easier than question 6 and 7 and 8, just because the numbers are less confusing. But there you go. That's how you do question 9. Okay, so you can do the same for C and D with the same techniques. Rearrange all of the equations and find your A, B, and C. Work out your discriminant, sketch the discriminant graph, and then analyze it to answer the questions. Okay. There you go. I'm going to pause it there because I think it's gone on for a while. But hopefully, if you watch the questions for 5, you got your 6, 7, 8, 9, and I've done question 12. We're just missing 10 and 11 right now. Yeah. But it should be more than enough for you to get a good feeling of chapter 3 on exercise 3.